So let's begin 9.6. In this section, we move to graphing quadratic functions. So it's called graphing quadratic functions using properties. So it turns out the book has another section on graphing quadratics that we are not going to cover. This one all about using the properties. So let's check it out. We're now going to think of our quadratic as in the function form, f of x equals ax squared plus bx plus c. And so let's kind of begin the conversation. We'll go through what the properties are and how to determine the answers to all of the properties in the first video. We'll get into examples in the next video. So one, we want to just kind of look at the shape of the graph of a quadratic function. So you might know, some of you guys might know, what the shape of the graph of quadratic is called. Of course, I'll tell you right here. It's called a parabola. P-A-R-A-B-O-L-A. And it will take one of two forms. And so I've given an example of each one here. Trying to center that as best I can. It's got this kind of like this U shape. So we call this opening up. And you just have labeled different parts of it, but the graph itself is this curve, like so. Notice it does not come down to a V shape, but it's got this gradual curve like that. If it's opening up the other direction, then again it's got this gradual curve and then coming back down, like so. In either case, there's a couple of different aspects of the parabola. So in this case, kind of mentioned before, we call this opening up. That's opening up. This we would call opening down. Okay. The next important feature, you notice that it's perfectly symmetrical. So you can imagine this invisible, I've got a dotted vertical line here going right down the center. We call that the axis of symmetry, that it's perfectly symmetrical. It's like a mirror image on either side. Same idea here. I can draw this dotted, this invisible line right down the center, and it's got a mirror image. Now, the line is not part of the parabola. The parabola is just the curve, but we can imagine that it being symmetrical about that line. Finally, the very lowest point or the very highest point that is also right in the middle, we refer to as the vertex of the parabola in either case, whether it's at the very bottom or the very top. And you notice that the axis of symmetry will pass through the vertex in either case as it splits the parabola. Okay, actually these are the first three properties. Which way does it open? Where is the axis of symmetry located, and where is the vertex located? Let's get into the properties, and I'm just gonna tell you all the properties here to start, and then we're gonna look in detail at each one of them. So the first property is simply answering the question, does your parabola open up or down? And it turns out there's a very easy way to tell based on the function. I'll tell you that in a moment. So once we determine whether it opens up or down, then we get the equation for the axis of symmetry. The axis of symmetry, it's always a vertical line. And as you might recall, a vertical line always has the equation x equals a number. So we'll have some number here. So I just left it as a blank. And that value of x tells us where to plot it on the graph, but it's the entire vertical line. Okay. Then, once we have the axis of symmetry, we can identify the vertex. It's an ordered pair. You know, it'll have an x coordinate and a y coordinate. I just left those as blanks. Okay. Property number 4, where is the Y-intercept? Which means where does it pass through the y-axis? And then finally, does it have any x-intercepts? So you notice I wrote x-intercepts, if any. Sometimes it will not have x-intercepts, but oftentimes it will, and so we can identify those. That's where it passes through the x-axis. Again, we're going to practice all these things, especially the intercepts might not be as familiar to you. We're going to go through this one at a time, how we identify these things. Okay, so starting with property number 1, how can we identify whether our parabola opens up or down if all we have is the function f of x equals ax squared plus bx plus c? So it turns out it's really simple. It's all about the value of a. Here it is. If a is a positive number, if a is greater than 0, the parabola is going to open up. That's it. We just look at the value of a. If that value is negative, less than 0, the parabola is going to open down. We don't really have to do any work. We just have to pay attention to a. Pretty cool. Okay. Moving on. How about the axis of symmetry? This is interesting. So we know that it's going to be a vertical line. It turns out it's the vertical line x equals, and then we calculate negative b divided by 2a. So we take the b from our function, the value of a from our function, and put them into this. Like, that's so bizarre. Why would the vertical line pass through the x value, negative b over 2a? Well, maybe that almost seems vaguely familiar. It's part of, like, this is the explanation just where that comes from. So if you remember the quadratic formula, isn't negative b over 2a part of this formula? I mean, we can see it right here if we ignore the plus or minus square root piece. That's so bizarre. Why would that give us the equation for the line that goes right down the middle? So it turns out the quadratic formula tells you x coordinates on your parabola, right? The x equals. If we take the negative b over 2a, that is the central, if you will, x value. Why is that? Because starting from the middle, we would then add or subtract that number right there, whatever that square root is. Well, if we're adding or subtracting, that's like we're starting in the middle. If you add, if you subtract, if you add, if you subtract. So where did it begin? Where was the center, right? You know, if we... that axis of symmetry goes right down the center. That central x value must have been negative b over 2a. Okay, of course we'll see examples, we'll calculate these things, we'll graph them when we get there. For now, just the explanations behind each of one of these. Okay, moving on. Hopefully I'm not going too quickly. The vertex. The vertex. So it turns out if you know the axis of symmetry, you've actually already done half of the work to find the vertex. The vertex is an ordered pair. It has an x coordinate and a y coordinate. The x coordinate we already know. It's negative b over 2a. Why is that? Well, I'll make this picture again. Remember, the vertex is right there at the center, either at the bottom or the top, depending. And if we know the axis of symmetry, then that x value is going to be the same as the x value for the axis of symmetry. It's also, the x coordinate, it's also negative b over 2a. Well, once you have the x value, how do you find the y value, the y coordinate? Well, turns out that's actually pretty easy. You take your x coordinate and you plug it into the function. Right? Isn't that that's how we find y values, right? If we take the x value and plug it in for x in the function, and then we'll have to calculate what that is, that will give us the y coordinate of that same point. Okay, again, if that seems confusing, all of this seems confusing, we're going to do examples. Usually things get a lot more clear when you see actual numbers you have to work with. Those are the first three properties. The last two properties are about the intercepts. So we'll start with the Y-intercept. And just to give you an idea of what the Y-intercept looks like graphically, it's the point where the parabola passes through the y-axis. Where is that point located? If we can tell where that point is on the y-axis, that'll make things a lot easier to graph, because we can plot that point, give us an idea of how to draw this curve. Okay, so we're going to think of our function not as f of x equals, but as y equals. Let's think of it as y equals ax squared plus bx plus c. Okay, how is that going to help us identify where that passes through the y-axis? Let me ask you a question. What is the x coordinate of any point on the y-axis? What is the x coordinate if you're located right there? Doesn't it have to be 0? Isn't the x coordinate 0 right there? Now, we don't know what the y is. That's what we got to find. But we definitely know the x coordinate is 0. So here's what we're going to do. Using our function, we're going to set x equal to 0, and we're going to figure out the y value. Right? If the point has an x coordinate of 0, we can plug 0 in for x, get the y. So in the end, it's going to look like 0 comma something. And once we figure out that number, then we got it. Okay, so usually the y-intercept, once you get a handle on it, doesn't give people, it's pretty fast, right? If you plug in 0, then, well, isn't it always going to be the c? Okay, well, yeah. Again, we'll do examples here in a moment. I'm probably going way too fast right now, just to summarize these steps. The very last one is the x-intercepts, if any. So again, we're going to start with our function, thinking of it as y equals ax squared plus bx plus c. And if I was to draw a picture, I didn't do it for this one, but maybe, maybe our parabola kind of does something like this. The x coordinates would be where it passes through the x-axis. Excuse me, the x-intercepts are where it passes through the x-axis. Oftentimes there are two of them. Right. And it's really the reverse thinking of the y-intercept. What are the y-coordinates? Isn't the y-coordinate 0 at both of these points? We just got to figure out what the x's are. So we're going to take this, and we're going to set y equal to 0 this time, and solve for x. Now let's talk a little bit more about that. If we put the y as a 0, and you see, okay, this is what I'm looking for. Hey, if I make that y a 0, does this look familiar? 0 equals ax squared plus bx plus c. I can solve that using the quadratic formula. Okay, so these are the 5 steps, the 5 properties, if you will. If we can tell whether a graph opens up or down, where its axis of symmetry is, where its vertex is located, where its y-intercept is located, and where any x-intercepts are located, that will be plenty enough for us to plot out enough points and enough things that we can then draw that curve ourselves. We are going to do the first example in the next video. See you there.